Hey everybody, welcome to Houdini Hangout. We're at the end of November here, just in front of Thanksgiving for some of our US folks, if you celebrate that type of thing. Still a pretty busy holiday around here, so if you're joining me tonight, thanks so much. If you're joining me from the US, I should say. If you're joining me from somewhere else, greetings. Glad to have you with us. And yeah, hopefully it'll be an interesting evening tonight, and we can play around with a little bit of feathers. That's what I'm looking forward to doing tonight. And it's been a long time coming for me because I've been able to play around with some of these features for a little bit. But yeah, hope everybody's doing okay out there. Things have been a little busy for me recently, but not too bad. It just so happened that I had stuff come up the last few nights. Turkey feathers to keep it on brand. That's interesting. I hadn't thought of that. Turkey feathers. Yeah. So I just had a few things come up recently, and it's just kind of derailed my streaming plans. But I think we're here. Here we are. We did it. Yeah, like I said, I've had the good fortune to be able to kind of play around with some of these features for a little bit now. Had been kind of preparing some materials for instructors and things like that I actually am just finishing up. And it was just a while of working through how these feathers work and all that kind of stuff. So it's not that it's that complicated. There was a few things that would change here and there as kind of the lead up to the release came. So it was, a little bit of just kind of staying on top of what was new and what was going on. So kind of cool to be able to be on that side of things these days for me. But also it made me excited to realize that I could certainly bring that information to you guys and share it. Hey, Zach. Hey, KG. Welcome to the stream. So tonight, like I said, we're going to do some feather workflows. We're going to talk about what feathers are, what they aren't, and show some different ways that we can kind of, at least show a basic workflow so that you can kind of understand where that is, kind of how that works and everything, and be able to use it in your workflows wherever you might be. The one thing to keep in mind here is that not only have these feather tools made it possible to work, with a feather object in Houdini, with a shaft and barbs coming off of it, but it also has improved the way that people are able to do grooming as well in Houdini, and that will continue to kind of, I think, be a symbiotic relationship between the two because of how closely the two technologies work together. So I think there'll be even more alignment between those two kind of worlds of regular hair grooming and now of feather grooming. So hopefully we'll see some of those crossovers and you can start to understand how that works. KG, I'm just seeing in the chat you're talking about a collaboration that's acted with a guy, Ross Mason. I'd be interested to see if you could drop maybe you can't put a link in the chat. That might not work. If you can put a link on the Discord, can't verify my phone number on Twitch. No problem. Yeah, anybody can feel free to hop over to Discord if they would prefer to chat there. The live chat kind of updates there as well. So feel free if you're watching on YouTube or Twitch and you're interested in switching over to Discord to be able to have quicker conversation. I will get that probably message way faster that way than if I'm if I'm checking through some of these other resources and stuff like that. Only scales left. Oh, I see what you're saying, Carlos. Yeah, only scales to cross out. Well, I know that there's actually some pretty nice HTAs out there for scales that people have made up. So hopefully, that won't be, we won't kind of step on those toes too much and let those kind of have their own life a little bit as well. But yeah, no, for sure. Yeah, there's scales out there. I mean, I'm sure there's plenty of things. I think for an interesting thing to kind of, hey, I will say Shrey. I don't know how to say the full name there, but hey, Shrey, welcome to the stream. Hola. I would try to speak some Spanish, but it's been quite a few years since I was doing that in high school, so I'm not going to embarrass myself in front of other people, but hola. Um, yeah, so one of the interesting things to kind of talk about here is you know, why did we choose to do feathers, I guess? Why did side effects choose to do feathers? Why now? I'm going to just speak from, not from a spot of, me speaking on behalf of the company, but just from what I've kind of gathered from different conversations and things like that. But, you can obviously hear from Kai directly in his FMX chat or in the release information that he kind of did for the actual keynote presentation. And I don't know if he did I don't think he actually did a presentation at the Hive after. But anyways, if you want more official stuff, they can kind of talk about the official discussions that happen behind the scenes. But what I understand is that, there's been a lot of different ways to be able to go about making feathers over the years. And so we, I think, took a lot of time to have conversations with different, studios and people that are, kind of power users of Houdini, and to see what their methods of making feathers have been, and how can we take what they've learned and make kind of a streamlined official thing. Because once Side Effects makes something, it means that that's the official way of doing it, right? Or that is like a rubber stamped kind of thing. And so that has to be done with a really careful, just with a lot of care, basically. And to make sure that it isn't something that is just flippantly done. So that's kind of where we are right now. And like scales, yes, certainly is a thing, but and there's, I'm sure, other character elements. There's other modeling things. There's all sorts of different things like that. But as far as taking the time to actually put together something that's like official, that takes a little bit and takes a lot of conversations. And I know Kai's really kind of knocked it out of the park with this whole process overall, and it's only going to, have improvements going forward. So excited to kind of see where that goes in the future. So as we're going through this, like always, please feel free to drop down a message in the chat. I'll probably even, ask for some feedback from you guys throughout this whole thing, as I try to do from time to time. But if you have any questions or something's not clear, please feel free to drop a comment in the chat. Happy to take a look at that. Like I said, we're on YouTube and Twitch or Discord. If for some reason you get locked out of those two chats, I know sometimes links can cause the bots on there to get angry. I've tried to turn everything down as much as I can, but I only know how to do so much with all the different streaming things. So I think I've got all the weird stuff turned off as much as I can on my end. So, but otherwise, I think, oh, cool, Zach. Yeah, great. I'll have to take a look at that. Very good. Awesome. Yeah, I'll have to take a look at this Ross thing you did with Ross. That's cool. I'll have to remember to take a look at that. Let's see here. Mark that on red so I can come back to it. Did I see Max Rose's introduction to Apex? I don't know if I did. I can't really I don't remember seeing it. Or at least I definitely didn't watch it in depth. I can't remember if I saw that it was what the video is you're talking about. There has been a lot of really cool talk about Apex, and I'm personally really glad that it has gotten the interest that it has. I think I was, just with any new technology coming out, you're always kind of a little worried to be like, ooh, is this going to be ready for people to use and play around with? And it certainly is early for it, but it's really exciting to see how far people have been able to take Apex already and play around with it. And from a technology standpoint, it's like, it's in like 4-dimensional chess world where it's just like, it's doing stuff that's hard to even process in my poor little brain. But, it's doing some really cool stuff from what I can understand. And I think as they said, it's only for rigging right now, but when those other uses come into focus, I think that will be make it easier for people to be able to understand what's going on with that kind of new, it's not a context, but that new kind of programming language, that new execution type thing. it's definitely interesting. But I haven't personally dug into Apex at all yet, just because there's too much Houdini to go around for one person. And so internally on our team, we have a little bit of division of knowledge so that we can try to cover more of the program across all of us. So I haven't touched it personally yet. I have seen a lot of talk about it, and I've heard a lot of conversations, but haven't gotten in there and really messed around with it too much yet. But maybe we'll get to that someday, but maybe not this release cycle. Maybe it'll be down the road, next release cycle. I'll play around with it or something. I don't know. We'll see. But anyways, always, as I don't need to keep talking. As always, with these live streams, if you have a question or comment, please feel free to put it in the chat. Always interested to hear from you guys as far as like if there's something that's not clear or something that I could be doing better, or you have a better way of doing something, you want to share it, please do, because I often learn stuff through these streams that I didn't know before. So it's as much a learning experience for me as it is maybe for you. But I guess with that said, feel free to put your comments in the chat and we'll get in and do some Houdini. So let's get over there. So I think what we'll do is just start really basically with how feather templates are made. And then we can kind of go from there and see what some other ideas are, that we can kind of play around with. So the first thing, obviously, like always, we'll drop down a geometry node, and I'll call this feather template. All right, that looks good. And so let's come in here and let's do a feather template. Now, when you use feather template, it's going to drop down 3 nodes. This is kind of the basic building blocks of the feather system. We have a curve, we have the feather shape organize, and we have feather template from shape. So the curve at the top is kind of doing the artistic kind of controls here. So let me switch this background over to dark gray, and we'll take a look at what's going on here. So here's our curves. We have 3 curves here. The center one is going to define where the shaft is, and then these 2 outer ones are going to define where the kind of boundary of the barbs are going to be. So that's an important kind of thing to know how this is working. The feather shape organize doesn't have any parameters on it. It's just a node that does stuff inside of it. And basically it organizes all the incoming data so that this feather template from shape can do what it needs to. And on this node, this is kind of where we set up some of the base parameters for these feathers. So let's just take a look at what's going on here. So we've got, you can set your barb density here. This allows you to have more or less barbs above the base section of the shaft. So that's what this barb density controls. Shaft density, I'll turn the point view on so you can see. So the shaft only has 2, just has 1 segment, but we could turn that up and put more segments down there. Let me make these a little bigger just so we can see them. I'll just double the size of them so we can see the points. Cool. All right. So now you can see we've got lots and lots of points here in the shaft area. We'll just go back to 1. We don't need to have any more than that. And a couple more things here too. You can see we have the width root and the width tip. What that is going to do is control the width of everything as we get from the root and as we go up to the tip. So here you can see, let's make this a little clearer. So we'll do 0.02 maybe. There we go. And I'm going to turn the points off. And you can see that we've got a nice thick base to this kind of feather shaft. And as we come up to the top, we're going to get thinner and thinner barbs that are going to exist up here. And so this is going to be kind of a multiplier that's going to exist. You can see this is obviously going to go, we could probably bring this down a little bit. You'll see this fall off that's happening here. So at the very tip, we're going to have this really, really small width to those barbs. And then as we go down, they get thicker and thicker. So one thing to keep in mind here, I'm just going to set these back to default. 0.05, I think, is the defaults, if I'm not mistaken. Maybe it's one more. They're very thin by default. There we go. So one thing to keep in mind is that whatever points or whatever width you set on these points will also travel down these barbs. And I think this is a good point to discuss what's going on with these barbs, because I have my point display on and there's no points being displayed with those barbs. Let me turn the resolution way down on this and we'll get a better look at what's going on here. I guess we could turn the width of these up a little bit too, just to see what's going on here. So we have this shaft, and the shaft has points on it, right? But these barbs do not have points on it, which is a little strange, right? So what's going on here is we actually have attributes that are setting the point positions for these barbs. So if we look here, we have in our geometry spreadsheet, you can see that we have our P barb L, and that's an array. And then we have P barb R, and that's an array as well. So if we middle click here, we'll see that we have P barb L, P barb R. They're both 12 floats, which means that there are 4 points that are being described for these barbs. So the root, and then 3 more that define it along its length, all the way to the tip. So these are virtual points that are being drawn from the GPU. These are being drawn based on attributes that we're giving to the graphics card to draw these in the viewport. So it's not actual geometry. It's just an attribute that's being drawn. There's also a UV set that's like that. There's UV that's just defining the UV of this center shaft. And then there's 2 UVs for the barbs on either side. So that's how we can have, hey Epoxia, welcome. So that's how we can actually have a UV grid on these kind of virtual points. So hopefully that makes sense and is kind of, you're starting to see some of the kind of special nature of these feathers. These feather templates, we usually call them like feather templates or condensed feathers because all of that data for all the barbs live on the actual shaft. We can actually uncondense the feathers as well. So we'll show that in a second here where we can actually turn this into geometry. The really only other thing that's happening here is just a little bit of like naming and grouping. So we can set up the name here. We could call this like turkey feather or something like that. And you can see here, this is turkey feather. You could set what side it's on, whether it's a center, left, or right. That'll come in handier with the grooming side of things. And actually, this is a little bit of a later addition to this whole tool set. And I haven't really played around with that side too much because I've been doing some smaller kind of example setups, not really getting into full groom. So I haven't really had a chance to fully explore how this center and left and right kind of work. It's probably more for the mirroring side of things. If you're mirroring your feathers. I'm also not a grooming artist, so I'm not like, this is not my specialty by any means. I'm just have had some time to learn this stuff. So happy to kind of pass that information along. The only other thing I guess that we can, well, a couple things we can talk about here. Normalize just sets this feather to be within the 0 to 1 range. Now we can see that this already exists between 0 and 1, so that's not really going to do a whole lot. And then move to origin would obviously move it to the origin. That's just if this was somewhere else. So if we did like a transform, let's just do some weird transform on these curves here for a second. CG Fairy, that's really funny. Complete beginner watching cool feathers, and then you stop the video to go see how to change the background color. Yeah, if you want to see that, you hit D, you go to background, and there's a few different options in here. There is a regular gray, which is horrible. I hate that. There's a dark, a black version, a light, and a dark gray. The dark gray is new. It used to be a labs thing, and now it's just regular in Houdini. Anyway, so let's scale this a little bit and maybe like rotate it oh, that's the wrong way. Let's rotate it a touch and just see what happens here when we do some of these things here. So you can see it just jumped right back because I had normalize and move to origin on. So we could do a few different things here. Turning on normalize will make sure that it's within that, that 0 to 1 range, and moving it to the origin will, no, actually, it's not changing it to 0 to 1. That's interesting. I thought that's what that did. Sorry. Yeah. Light mode Houdini Fields old school. Yeah, for sure. Sorry. I think actually what normalize is doing, now that I'm thinking about it, is it's actually making sure that the center curve is straight. that's what the normalization is not setting it to within the 0 and 1 length. So my mistake on that. I was actually misunderstood that a little bit. But that's okay. It's basically center. It's bringing it to, kind of putting it in a straight line. That's more or less what you can imagine the normalizing doing. So you can see here when I click normalize, it just straightens it out perfectly in the same spot that it was in, and then move to origin would obviously move it to origin. So anyways, I'll just take that transform out. We don't need that. Cool. Hey, hello everybody. Welcome. Color settings. Sorry, just making sure I'm not missing anything in the chat. Cool. So that's the basic, kind of setup of a feather. Now we can obviously kind of push this a little bit further and do some other things, but let's talk a little bit more about maybe how we do these feather things, and then we'll kind of go into pushing it a little bit further and making some like interesting shapes and some interesting, things with it. So, what we can do is we can uncondense them. So if I do a feather uncondense, here we go. So now this is going to actually take this and turn it into actual geometry. So we can see now we have points and lines for every single one of these barbs and the shaft. So if I do S and 4, I'm going to turn my keyboard display on so you can see what I'm typing. Here we go. So now I can select these. These are all actual geometry. Everything's cool. And I could use anything to kind of modify these if I wanted to. So like I could use something like a mountain here, make some crazy noise to it. Now, unfortunately, this is getting a little crazy. So let's turn off the noise along vector. We'll turn the amplitude down a little bit. And we'll get this kind of crazy looking feather here that's all sort of warped and wonky. That's looking cool. That's at least something. We can see that we've moved these points around. You could obviously adjust this however you might want it to look. But there we go. We've got some feather movement. Now, what if we wanted to get this back to not being all selectable geometry, right? Now we've got 883 points, whereas before we had 99. So you could obviously see how this would get kind of out of control if you did this on a huge number of feathers. I don't know. Hey, I don't even know what your name is. Welcome to the stream, La Pampadura. Yeah, sure. La Pampadura, welcome. Yeah, I'm doing great. Hope you're well too. So let's say we wanted to take this and bring it back to these condensed. Well, you see we have the feather uncondense. So if we type, let's see, match uncondensed right here, this will allow us to match our uncondensed feathers back to how we had them before, where it was just the center shaft. So let's do this. We'll take our feathers here. Here it is. This is our, it's airing out because we haven't given it everything it needs. It also needs our uncondensed feathers on input 4. So the really interesting thing that happens here is that when we use this node, it takes the point positions from here, from what we kind of modified with the mountain, and puts that into into attributes on these points. So we can see here that if we go to our points here and look at, sorry, wrong node. If we look at our point positions here in this array, as we turn this on and off, those are all going to change. So it's just these attributes that are changing. It's also changing the point positions of this curve itself. So these point positions are changing as well. Here you can see they're all at 0, 0, blah, blah, blah. And when we turn this on, we get all this noisy position. So that is controlling where that all happens, right? And so it's taking the data from those point positions and turning those back into the kind of 3 float vector pairs in that array that it's using for each of those point positions. So if we think about it, P barb 0, 1, 2 is going to be the first point, 3, 4, 5 is the second, 6, 7, 8 is the third, and so on. And that's for each side. Looks like a very precise FFT. Yeah, it's definitely a lot of floats. I think for something like a matrix, you would do 16 floats usually. And in that case, you would, if you added you wouldn't get to 16 with this because you're doing sets of 3. So you get to 15. So it does look like these huge kind of arrays, right? These huge kind of almost matrices. And so here with the barb segments, we could actually turn this up as well. So as we turn up the barb segments, we're going to see that grows and we get more and more segments here to be able to kind of work with. Now, I'm uncondensing them so you can actually see the number of points. Otherwise, it can be a little hard to see because really the difference between, like, here's the condensed feather where it's being drawn on the GPU. The difference between, here at 3 where it's default and like 8, I mean, it's changing a little bit, but I doubt you're going to see that too much on the stream. So you'll see this when you get really intensely kind of bent feathers, and we'll talk about that a little bit more when we get to maybe a more specific example. But this is, I'm actually just going to call this basic feather template, just because I'm going to be giving this out later, and it'll be easier for you guys to know what the heck I'm doing. Zach, are the attributes in these condensed feathers live? Like, can they be modified by an attribute wrangle while condensed? They sure can. Yep, 100%. In fact, there is a node that will respect the barbs, and so you can tweak these at any time. I mean, obviously you need a little bit of math there to kind of figure out exactly which point corresponds to which thing. Even easier, what you could do is you could do something like the feather noise. I'm just going to do this, make sure we're on autosave just in case I do anything stupid. So I get these little errors that come up. I think that's just a warning for starting up OpenCL. Sorry, that's a weird little glitchy thing. What the heck just happened there? I noticed this the other day on this computer that I was doing that. So with this feather noise, this is actually going to add noise to the barbs themselves, and we can actually control that right here. So this is a pretty cool little node. So you can see here we've got some like fall off that'll control how far out and towards the center it'll go. So here you can see we're kind of controlling where that noise happens, and you can set it to be different amounts of noise in each of these axes, right? You can do it along the tangent or along the bitangent. We can set up differing amounts of noise here, all sorts of cool things. And then also there are these overrides that can be done here, and those can be driven by the new texture primitives as well as from attributes along this spine here. So if we just did something like, let's do a resample. I'm not going to actually resample anything, but I'm just going to use this to grab a curve view. I think there's another way to do this these days, but that's okay. So we have a curve view on this center spine. And what I could actually do here is change the amplitude based on, I think a guide attribute would be what I'd want. I can use curve view, and it's just going to calculate for a second there, I think. Hopefully. Yep. So this is all OpenCL. All of these different nodes. So sometimes what you'll run into with these are a little bit of like compiling time to be able to kind of have these upgrade and stuff like that, or update, sorry, not upgrade. But there's also like this ramp here, so we could control, along the length of this, now that we're using curve view, we can control this along the length of it. We could probably up that a little bit as well. We can see that as we change the location of this, it's going to have, kind of move along this noise more or less top to bottom like that. So again, we're just using this curve view for the amplitude and kind of just driving that with the ramp. Lots of different things that can be done here, obviously. But this is a node that actually knows about these barb attributes. And when you look at some of the, what is it? Is it process, guide process, I think? Yep. If you look at things like this, there's actually, let's see, bend. Yep. There's actually some of these guide processes that actually have things like feather barbs in here as well. So some of these nodes actually know about what feather barbs are. You can set left or right, and it will actually do things like bend them and things like that. We're not going to get super far into all the grooming side of things, just because, like, again, I'm not a grooming artist. I'm not like super skilled in all these different ways of what's the best way to kind of do all this stuff. But hopefully you'll see some of these ideas kind of unlocked, and you can go and play with those things on your own. So this kind of idea here is if we were working on it with just the condensed feather, obviously we're not moving the shaft itself in this case. We're just noising up the barbs, but what it's really would make more sense to do it in a situation like this where you'd actually have noise for these individual barbs. Here, when you're putting this mountain stop and bending the shaft like this is pretty weird. Like, that's not really a good example of how you'd want it to actually work. So, your mileage may vary, but it's certainly something interesting that you can do with it, right? So these are kind of the two different ways that you could think about working in, along this. So this is kind of the, I'll just call this uncondensed edit. And this is we'll just say this is a condensed edit. Just to kind of clarify a little bit here. And I'm just going to organize this a little bit just so that people can see what the heck I'm doing. Okay, cool. So hopefully this is all making sense on some level. We've got these curves that have barb attributes. Those barb attributes are drawn on the GPU. And one thing to note too is that there was a lot of talk about the Vulkan viewport. And to be honest, I don't know the tech that goes into the actual drawing of these barbs, but I'm pretty sure that it's already been done with that in mind. And I think there'll be some significant viewport performance when the Vulkan gets kind of implemented as the actual viewport in Houdini, and not just in a sort of experimental state. But as that gets actually implemented, you're going to see, I think, some performance improvements with that as well. I remember Kai mentioning that at some point. If you don't know who I'm talking about, Kai is the developer at Side Effects that has actually done the work with this. He did the talk at FMX and also at the launch presentation. So if you haven't seen those, that's kind of straight from the horse's mouth, and you can go hear that. Now, FMX is a little bit ago, and some things have definitely changed since then. At that time, he didn't have a feather procedural for rendering, and I was laughing because, like he said, I was watching. I don't remember if I was there at the presentation, but I definitely watched it after the fact, and it was like a couple weeks later that he posted on our Slack channel, "Oh, I got the procedural figured out," and it was like, dude, you guys are crazy. I don't know how you could like just go, well, I'm hoping to have it for launch, and then like weeks later be, oh yeah, I kind of figured it out. I think this is working, and it's like, okay, cool. You guys are too smart. Anyways, so cool. Hopefully this all makes sense. If you have any questions, again, like I said, drop them in the chat. I'd be happy to go back over anything. This is like, again, the simplest example. There's nothing crazy going on here. We're just kind of getting the process kind of figured out. And what's going on here? Why is there we go. Something happened with my mouse. That was weird. Cool. So this is the most basic feather template. Let's maybe take a look here and see if we can't. Oh, yeah. Cool. Oh, yeah. This is what I'm talking about. So if you're looking for feather atlases, as they're called, the U.S. Fish and Wildlife Service has you covered. Because they're apparently just putting out feather atlases for different birds, which is really fun. So I think if we let's just do this real quick, and I can probably get back to think I can just go to this. Yeah, thank you, Feather Geeks, right? So this is the beautiful, I mean, it's ugly as anything, but this is the feather atlas for North American birds. Now, sorry to Europe and all that stuff, but this is what we got. This is what I know about. So if you want to find some crazy bird on here, go for it. If you want to find like a hummingbird, looks like, see, swifts or hummingbird. Let's go hummingbirds. So there's, how many of these are there? Let's see, list view. Yes, there's, oh man, I don't even know what these things mean. Anna's hummingbird, tail. So here's tail feathers from a hummingbird. So like, if you want to get into this level of craziness, you can. And the really cool thing is that these aren't just like, oh, here's a picture of it. It's to scale, everything. Like, yeah, thank you, Feather Nerd. Like, look at this stuff. It's crazy. Like, I can't even handle it. But oh, we got some goofy thing. Okay, let's check this out here. Let's go back to results. Let's find. You know what? Let's just do it this way. Can I do search a scan? Common name. How about turkey? I don't know the. Oh, cool. Turkey vultures. Yeah. So you can see here, these are sort of the type of feathers you would expect from, what's the word? Like, kind of more powerful, fast flying birds. They've got these, I think they've got these spikier feathers. Here we go. Wild turkey. Now we're getting somewhere. Let's see. Can I do this? Wild turkey? Sure. I mean, we're getting somewhere here. Let's see. Wild turkey primaries. There we go. I don't know what half these things mean. So you're going to have to do a little, I don't know what a reticras. Oh, those are cool. Those are kind of neat. Yeah. Who knows? I don't know. I'm just going to find something and we'll just go with it. Yeah, maybe we'll just do let's just do the primaries for now. Yeah, I just think we'll just take a little detour here and just say, I love that there's nerds of everything. It's literally one of my favorite things in the world. I am very happily self-proclaimed nerd. Now feathers aren't my thing. I will share my one nerdy hobby. And that is, well, one of my nerdy hobbies was roller coasters. I used to know all the roller coasters in the US, in North America, more or less, and over a good portion of the world, and their layouts, stats, all that kind of stuff. That was one of my nerdy high school things. Whatever reason, that was super into roller coasters. So that was my weird nerdiness. So, but I love when you find these other little like niche things. Like, it's just so great. But anyways, all right, let's get this. Let's get this picture. Where do we get the picture from here? I guess we can just save the image as, right? All right, let's put this in Houdini Hangout. Sure. Make a reference image here. So the one thing I'm going to do is I'm going to turn this into I'm going to make some like a grid geometry to use in here. Nerdiness is Houdini. Yeah. Oh yeah. I did actually do a lot of traveling. I'm kind of lucky in the Northeast. There's quite a few theme parks and stuff like that, but I've traveled around a good bit. Like I've ridden most of the roller coasters like in Florida, and I've been up and down the East Coast a little bit. Definitely I've been on almost every different kind of roller coaster. There's not many types that I haven't ridden. So yeah, I know just from looking at them, I know like what manufacturer made them and all this. It's really ridiculous. My wife just thinks it's so entertaining to her. Also, I started liking roller coasters before when I was still afraid to ride them as a kid. So I was obsessed with roller coasters, but I wouldn't ride them. So anyways, that's another weird thing that my wife just found out about this. Anyways, yes, I can always notice when a roller coaster isn't good, or, when there's, when I see a roller coaster in the background of like a movie or something, I was like, what was that? Be like, oh, okay, it's that theme park. So anyways, that's my nerdy thing. So feathers aren't my thing, but roller coasters are. Anyways, all right, so let's do feather reference. We'll just do this like that. I've only ridden once. Yeah, roller coasters aren't that scary. I've been on the tallest one in the world, and it's really not that bad. It's really quick, like literally and figuratively. I mean, it goes like 128 miles an hour, and it's like 400 some feet tall. I'm actually afraid of heights too, which is really weird. But roller coasters took me away from that. So do a procedural roller coaster scene. Actually, my coworker Michael did a workshop recently and actually used a roller coaster example. So maybe that would be a cool thing for me to grab from him and kind of like walk through it. But anyways, all right. So we got our feather reference image. Let's do a grid here. And oh, the one thing I'm going to do, I guess, just to make sure that we're sort of doing this right, I'm actually going to open up another program real quick here. We're going to open up Photoshop because I'm going to make this square real quick. So got a grid. Let's just do UV project. I always do this the wrong way. So let me see. Scale, sure. Actually, no. Let's just do this a 1x1. And then we'll set this to be defaults. Cool. And what is it? Is it here? Is it -1 like that? There we go. Hey, look at that. I did it right. Oh, so my wife usually uses this computer, and it's over on my other secondary monitor because this is a Wacom next to me, a Cintiq, and so she always draws on that. So she's going to be, why is it opening on the other screen the next time she opens? I'll be like, sorry, I used it on the stream. All right, so let's okay. What's happening? Hello. Come on over, Photoshop. All right, let's open that up. We'll make it square, be done with it. Here. I think this is one of the first times I've used another piece of software on the stream, which is kind of funny. Hello? Didn't I save it there? Oh, I guess I didn't. There we go. I use a Wacom for work. Yeah, a lot of people do use Wacoms. I'm always surprised the number of people that do that. I mean, I tried it for a while and like gave it a shot, but I don't know. I think I'm faster with the mouse, and it's just, I don't know. I can be a little. What's happening here? Maybe I'm losing my mind. Save image as. Hello? What's going on here? I've fallen into some sort of weird black hole where this is not going to work. Hold on. Sorry. Because this is where this gets fun, so I want to make sure I'm doing this right. How could that be empty? Downloads. Failed network error. What the heck does that mean? Excuse me? Okay, whatever. Yeah, I don't know what the deal was there, but opening it in a new tab and saving it that way worked. So I don't know. Weird. Anyways, there it is. It's like, do I not know how to open an image in Photoshop? Yeah, I guess you could do that. I'm just weird. I just needed to do it the right way, you know? Sometimes I just have to do it the most difficult way. All right, here we go. Actually, what I'm going to do is just unlock this real quick. Make sure that this is square so I don't have to fuss with this. like so. Solid color, black background, done. All right. There we go. I think we're done with Photoshop. Let's just do that. Cool. Done and done. Let's do this. We'll do a material network. And I'm sure Win Shift S, fastest method. Cool. Didn't know that was a thing. All right, let's just do a principled shader because that's the quickest way to do this. We'll get a texture, base color, texture, reference image. We'll grab the square one here. Surface, I'm just going to make sure this is white so we're not getting any shading there. And we'll say turkey feathers. All right, there we go. We've got our turkey feathers looking like an image. Cool. Let's just do a null here. We'll say out image reference, or we'll say, since I did reference image, like that. Cool. I think that's all we'll need. Okay, keep it wired up. I think that's all we'll need. So we've got a reference image. Now, what I did originally was I originally had done this with like a reference image. No problem, CG Fairy. Welcome. Thanks for joining us for a little bit. Happy to have you on the stream, and you can always catch up tomorrow if you want to watch a little bit more of me messing around with some feathers. So what I actually did before was use this reference image, but it's actually using a cop, and so I didn't figure out an easy way to be able to bring it in and do all that kind of stuff. So using a grid just feels a little easier. It's geometry already. So I think what I'm actually going to do, is I'm going to come back in here, do a transform at this level so I can line this thing up with, the overall scene or whatever. So let's do pivot mode. We'll move this over a bit. Where is it? There it is. Put this over here just so we're nice and kind of at the origin of this, and we can kind of keep it in a nice, there's a key shortcut for that, but whatever. All right, so there's the pivot transform, and we can bring this, let's see, I think if we do copy parameter and invert this, I think that is what we want. So we'll do negative, 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 like that. All right, now we're at 0, 0. Cool. And we can now just scale this properly. So centimeters, let me think here. Jeez, my brain, my poor brain. 100 centimeters would be 1. So we need this to go to, what we can easily do is kind of see these grid marks here, right? And we can go to, actually, you know what? I'm just going to delete this because I'm going to bring it down a little bit. See you, Fairy. Have a good night. So what I did before was there's 5 of these. So this would be 20, 40, 60, 80, 100. So what I'm going to do is just line up this mark right here with 20, and then we'll have this nice and kind of scaled properly. So that's just about right. So that should be 20 centimeters. These are now to scale, and that's great. and kind of just eye it up that way and get some nice looking feathers. All right, cool. So that's great. We've got a reference. I think what I want to do is play around with one of these ones where we've got a little bit of splits and some fun little like noisiness here. So let's maybe do that guy. That one looks pretty fun. Since we're doing our Thanksgiving stream here. So we've got our feather reference image. I'm just going to leave this here, and we're going to say another geo node, and we'll say turkey feather template. Cool. So let's go inside here, and what we can do is let's just do some curves. That'll be the easiest way, I think, to go about doing this. So let's do a Bezier curve. And first what I'm going to do is draw the shaft. Now I think I had a conversation with one of the other guys that I work with, and I'm pretty sure that you want to always draw these all in the same direction, just for the sake of the node being able to process it all properly. He was like drawing it and like up and down, like going up one way and then down another curve and then up the last curve. And it was like freaking out the setup, which probably is something that could be enhanced in future versions. But for right now, we're going to go bottom to top. And I think that'll get us the best kind of looking, or that'll make it work the best. So let's start from here. We'll just draw a curve going up this way like so. That, and then we'll take that at the end. There we go. All right, so that's the center shaft. Then I'm going to draw this kind of curve over here. We can obviously always tweak this in a second if I draw any of this too poorly. Oops, added an extra control point there. And let's just do this here like that. Cool. And then we'll do one more down this way. And I'm going to intentionally ignore this little split because we can draw that in a second here. So let's just do this. Kind of just draw this, kind of roughly the way it looks here. I'm not going to worry too much about it being perfect. So if we change this over to F, we can select these and edit them and stuff like that. So maybe we'll just do that there. Something like that. Cool. All right. So we have the curves for our feather right now. So let's throw this into a feather shape organize. Obviously nothing's going to happen right now, but let's also do a feather template from shape. Drop that at the bottom. And we got a problem here. Something happened. This isn't actually a problem, but it's a good thing to know. In order to view these feathers properly, you need to go up a level. Go up a level here and go into miscellaneous, shade open curves and viewport. That is important. There we go. Now we've got our feather shown. What that basically does is tells Houdini to actually draw those open curves instead of just leaving them invisible. And that also triggers it to be able to draw the ones that are just on the GPU. So important thing to keep in mind there. So here we can adjust the width of the root. I'll turn this. Let's see. I'll show all objects. So yeah, no problem. Yeah, black voxels. Well, yeah, I think it's a nice little, it's a nice tip, right? To know what's going on there. So I'm going to set the root somewhere in there. That looks like that's about the thickness at the root. And let me turn these points off, see if I can see what's going on here at the tip. It's probably going to be in that range there, I'm guessing. I'm just going to kind of roughly estimate it. So what we can see here is we have our shaft density. I'm just going to set this to 1. This is kind of the root of the shaft. And the rest of the... Yeah, why the lines aren't rendering. Hopefully that'll be another thing that'll be fixed with the Vulkan Viewport edition. That would be my hope, at least, is that that isn't going to be something that's always going to be the case, but just for right now will be sort of what we experience in this current viewport iteration. All right. So we have, oh, you know what? Yeah, let's just kind of see what we got here. All right, so let's play around with this a little bit. What you can control here is how closely and how the, I'm going to turn this down a little bit so we can actually see what's going on here. Yeah, these are a bit thick actually. So I'm going to turn this down just a little bit so we don't have such, actually, you know what? Sorry. I'm going to also do a feather width. So this one will set the width of the barbs as well. So I'm just going to say, oh, in fact, you know what? I'm just going to set this here. So let's just set these lower. Just do it like that. And then we'll use this feather width to actually control this. So now we can control these separately. They're not going to be working in tandem. So what I can do here is I can do the ramp. I'm just going to reverse that ramp, and I can set this to be, you know, the thickest section here that I want. I can set it down here for the tip. Oh, that's interesting. It actually goes down. Oh, that's kind of cool. Well, we could actually probably, yeah, we could actually do that. So here we can make this go down, and we can move this around a little bit like so. There we go. It actually goes down. Cool. That's kind of neat. And then down here at the end, we might just want to give it a little more thickness, maybe something like that. Cool. And then we can always turn the, so there's our ramp there. We can turn the barb widths down a little bit. So what this control here, this barb start on shape is doing is controlling how closely sort of it's matching up to the shape of this curve. So here's our curves, right? And so if I turn this, you know, up, it's going to try to kind of make this first, it's kind of controlling how far along this curve, the end of this first, the tip of that first barb is where it's going to kind of hit. So as we turn this way down, it's going to try to go all the way to the start here. And if we turn it up like this, it's going to kind of pull it along the length of that. So this is kind of a way to control how these, kind of a rough way to control how these barbs are being sampled here. Let's turn the barb density up just a little bit. And so the next thing you might say is, okay, well, that's all well and good, but like it's definitely doing some other things here. Like down here, it's curving a bit, right? So that's kind of nice. You want this to sort of start out straight, but like we get up here and there's definitely like something going on like this sort of a thing, it looks like. So how do we get that to work? Well, that's where the second input comes in. So we do Bezier, another Bezier curve here, drop it in there. And what we're going to do here is maybe add in some curves like so. It's like maybe we want it to be curving up there, and maybe up here it needs to go even steeper like this, something like that, right? So you can add in these other curves that are going to allow us to kind of get a more more defined shape going on here. I'm going to hit F to switch over to that mode. So you can see how, you know, how kind of intuitive this whole process is. I was talking to my wife again, she's a graphic designer, and I was like, oh my gosh, you could come in here and do all this stuff. It's not like, this is not this weird esoteric thing. It's actually really pretty practical way of doing this stuff. So we can draw these curves wherever we want to on this. I'm going to go back to G for the drawing part. And let's maybe just draw a couple more curves here just to get this a little straighter there. Cool. And then maybe up at the top, we're going to have it sort of, we could even do like a straight one there, something like that, just to kind of guide where these points are going to be going. Sorry, where the barbs are going to be going. Yeah, for sure. You could certainly use it to do something like that as well if you were wanting to. You could certainly use it to create some like veining on leaves and stuff. The only probably real problem there is that this only goes 2 levels, right? So you get the shaft and then the barbs coming off of it. If it was able to go another step, I feel like then it would start becoming more powerful, probably for leaves and other organic things. But yeah, I mean, certainly the possibility is there to take this and do something with it if you wanted to that was like that. In fact, one of the really neat things here is I'm going to turn off the other objects here. One of the cool things you can do is you can do a feather visualize. Drop this down. Now these have 3 nodes on them. When you're just working with feathers, you don't have to have these all connected. These are just made so that they work in tandem with the grooming tools, which have this feathers, which has the kind of groom guides here, the skin, and the VDB surface. So you don't have to have all these. It'll work just like this too as well. So, all right. So if we wanted to do this visualize, we could hide all those, right? All those, but we could also turn this into a surface. And you might be thinking, oh, okay, we've got geometry. Nope. This is on the GPU still. So this is not geometry. You can look right here and see that we don't actually have any geometry being created here yet. So this is a geometric representation of those same points, but surfaced, right? Those same GPU points, just with a surface. So certainly really powerful and really low, hit on performance. I mean, it's 24 points. There's not a ton going on here. Obviously, if we brought the barb density up to 500 here, it's going to drastically kind of change the way that this works. But I think this shows a really interesting thing here, right? This hopefully will start to click some things in your brain where you say, oh, hold on a second. Nothing really changed when I changed the barb density there, but I went way higher with it. So if we are looking at this in the curve visualizing, and we go back up here, say we set this to 1,000, right? It's going to look really solid. It's almost going to look like a surface, but it still is individual curves in there, which is great. It's obviously what you want it to be overall. But if you go down to something like 25, well, that's super low res. I mean, heck, 50 maybe is fine. Like it's a low number of points, but this is not going to visualize very well as far as showing you what's actually happening. But when you turn it over to a surface, it's like really pretty good at still showing you what the shape of these curves are, or these feathers are. And that's at 50. So if I go up to 1,000, it really doesn't change all that much. So yeah, it's UV'd in the sense of that there is a UV attribute that exists on those array attributes. So if we look at this here, we have a UV barb L, UV barb R. We also have a width barb L and a width barb R. So those are kind of those are 3 of the attributes that it'll visualize. And it will also visualize color as well. That was kind of a late addition. That actually came out after the Houdini went gold. They actually added the ability to visualize the width per barb and color per barb. So always sneaking little things in there, those developers. Oh, got a little like ghost. I just noticed there's like a little black mark over here and the background's not disappearing properly, but that's okay. So yeah, so these aren't true UVs in the sense of the way that just any kind of software would be able to see this is still like being visualized on the GPU. But when you uncondense them, that will actually convert it into actual UV attributes on those points. So it is a little bit convoluted, right, in some ways, but really efficient in others. So, there's some trade-offs there, but I think once you start to see how these things correspond, it'll make more and more sense. But I guess what I was getting at here was that you could have a really low resolution representation of this curve and still be able to see what's happening here. So you could have like a low quality, like an LQ version of your groom and work with that, change the, kind of mess with all the guides and things like that. And then have that, switch that over to a high quality. And it's basically just it can do all the exact same things just on a really higher mesh. So you can do all your really fast, procedural stuff and then switch it over at the very last minute to be the high quality version and then save that out or have multiple branches or whatever. Not UV as surface, but UV for visualization. Yeah, exactly. Yep. This visualizes where those UVs exist or where they will exist if you turn this into real geometry. But yeah, it is a UV. It's a little weird, but yes, it is UVs. It's just in those kind of float, kind of expanded float attributes. So, okay. Yeah, no problem at all. So we've got our width, we've got our feather visualize here we can use if we need to. All right, so we're getting some stuff going on here. Let's turn this back on so we can see this. Let's add this split in here because I think that's kind of a fun little thing to do here. So let's turn the barb density up. I'm guessing 1,000's probably about right. We're only dealing with individual, curves here or whatever. So that's fine. And in fact, we could probably turn the barb width down a little bit like so, just to see a little bit better of what's going on here. And the neat thing I can do here is I could actually not even visualize those. I could just come up here, right? And I could just draw in these splits. So I could just do this. I could just draw like this here, right? Oops. Sure. I'll just have this on so I can see where the, and then I could also do something like this here. That's a little sharp in the middle there. Let's just edit that. Cool. So now when I look at this, I'm going to actually have a little split there. So this is actually going to be splitting in that section there. And I can control, sort of how this split is happening, where it's coming from. And, we can kind of drive these barbs in some interesting way that suits our needs. So now we've got a little split down there. We could even maybe draw a curve down here to, let's go into here. Could maybe draw one this way. I don't know if this is going to work or not, but we'll give it a shot. Yeah. Looks like it's sort of working. Yeah, the only problem is it's kind of a little angry at me. So let's see if we can make this work. Yeah, so it looks like the problem I'm running into here is that this first curve wants to very specifically follow this right here. Let's see here. What I could probably do is turn this off. Let's see if that gets me anywhere better. Might not, but interesting. Oh, there we go. So we don't have to have the first curve follow that shape. So that's totally fine as well. Let's see. I thought we had some curves on this side that I drew. I drew them up there. Didn't draw them down here. So let me just draw a couple down there as well. Just for completeness. First one needed a refresh. Yeah, so I think it was just that it was kind of causing it to freak out a little bit. It when I wanted to follow that curve to start with, it wasn't happy with that. So that's a way to kind of make it work a little bit better. So so maybe something like this is a little bit, more appropriate way. Excuse me. So now that we've got these kind of actual curving barbs, we can come down here and see how these barb segments will actually smooth that out, right? So, you kind of have to figure out what's the best bang for your buck here, right? You don't want to go too crazy and put, because obviously what you're doing here is you're creating a lot of attributes to deal with. So if I put on 9 barb segments, these have turned to 30 float attributes, and you can just see that this geometry spreadsheet is going to be pretty gigantic now. So there's lots of, these kind of array attributes that exist in there. So, 5 maybe is going to be enough for you. Should be fine. Now, what I'm going to do is I'm going to do an object merge, and I'm going to bring in the reference image, so we don't have to have, oops, what's that doing? We don't have to have that in the background, so I'm going to turn that off. So now we've got that here. And what I can do is I can do a feather ray, and we're going to put the ray geometry in here. And so what we're going to actually get is we can actually sample the texture here, if I'm thinking about this correctly. Oh, yeah. So I'm going to put the texture path in here as well, because this will actually allow us to grab it. And there we go. Now we're getting that texture path in here, so we're getting some of those colors applied to the feather as well. It's not going to be perfect, and obviously if you put in a better texture for that than what I have, it's going to look better, but hey, it's what I have. So that's actually saving it to the CD attribute. So you can see we have CD, CD barb L, CD barb R now. So now we have CD, P, UV, and width that are all working on this feather. And I'm pretty sure that's the full list of what actually works as the on the actual barbs, like in the GPU kind of setup. The other thing to notice here is that, let's see, I'm pretty sure that if I do this and do UV, I can also grab the UV attribute from this object here. So I'm going to say get reference image grid. And so now we're able to actually pull attributes from that grid onto the feathers that were kind of looking at their closest point position on that grid. So we're getting the attributes to kind of come through to our actual the float arrays that exist on these points on the shaft. And so that's allowing us to be able to kind of get a nice additional little piece of control here. The other thing I'm going to do is I'm going to actually turn up the barb density, maybe 1500, maybe even a little bit more, maybe 2500, something like that. Cool. So what I'm going to do here is actually get, I actually probably could turn the feather with the barb width down a little bit. So let's do that. Cool. So let's take a look at this grid again here, and let's just maybe make some, we'll just kind of noise this up for fun. It's not going to exactly be accurate, but we'll show you how that works, and you can kind of see how to do that. So what we're going to do is we're going to use the texture mask paint, and we're going to need the geometry for this. So what I'm going to do, excuse me, I'm actually going to take this and put this into the skin channel, just like this. So this is not only going to be what the ray geometry is going to be, but it's also going to live in this this wire right here. It'll just make it a little easier to kind of keep track of what's going on. So there's our skin geometry. We don't have any volumes coming in here. However, we can now kind of paint on this textured grid here, right? So this is actually a representation of the geometry that we were using. Let's see here. So you can see there's our geometry. We can paint in between all of these points. It is not anymore, no longer tied to the actual resolution of the geometry to be able to paint mask attributes and things like that. We can actually paint them irrespective of the amount of points and primitives on the geometry. So this is obviously a really nice upgrade for stuff like this. I'm going to turn the resolution down. It doesn't need to be that high. We can just do it at 512. That's fine. It's just going to be a little mask. So let's do this. Let's do the feather noise. We'll use that. And now we'll kind of, so what we can actually do here is we could just do this. And so this is going to be our geometry. This is going to be our mask volume, like so. So those mask volumes go into the VDB input because they are they are volumes. So the volumes go into that one. So we've got this. Let's take our amplitude, which is now starting to kind of work on this. let's go into our texture primitive. We've got mask here. And what we want to do is do it with the, oh, sorry, just give me a second there. I think what it's doing when I switch these is that it actually has to, what's the word? It actually has to compile that code because it's in the OpenCL stuff. And so when I do that, it has to actually compile some new code in order to kind of show that properly. So I'm going to go back up to this texture mask paint. I should be able to paint this and have it work. Let's see. Just going to make this really intense so we can see something happen if I'm... There we go. I made it really intense. Okay. So let's just clear this back out, make this a little bit bigger. And in fact, I'm going to turn the opacity down by holding down A. Oops. Sorry, that should be the key command. There we go. So we're going to turn the opacity down. You can see it's changing in the viewport there. Sorry for all the A's. So this will be a little bit of a lighter move here. And let's see here. What I'm actually going to do is turn this off for 1 second. And I just want to get this dialed in first before I paint it. So I think we actually want to go pretty crazy with this. Yeah, there we go. Kind of really want to make it super noisy like so, because we want to kind of add in this kind of crazy noise to it. Super random. Barb frequency, I don't want to really change too much. Let's set the fall off so that it's kind of like that, maybe something like that. And then the amplitude is maybe there. I could actually maybe play around with this amplitude a little bit more. So now we've obviously got this really noisy and crazy, right? But since we can now override that with the texture primitive, now wherever we paint, we're going to have that work in here. So we can kind of paint some in here. In fact, I really think I want this to be on the skin UV if I'm not mistaken, but I guess it's not working that way. I thought for some reason that was how it worked best. Anyways, feather UV seems to be working just fine. So now what we can do here is we can kind of play around with this. We can make some noise here. We'll definitely do plants with it too. Yeah, it's a fun. I think it's really fun to work with, honestly. Like I said, I'm not a kind of like a grooming artist, but you can see how interesting this is, right? So I can clear this out. I could maybe even make this lighter and just kind of go along here and just kind of play around with this, make some interesting little noisy bits like so. And there we go. We get a little noisy feather situation going on. And there we are. It's all procedurally done, kind of really cool. So, okay, we've got our feather noise here. That's all going great. We've got our barbs and everything set up. We've got our attributes here. Oh, the one thing I guess we should kind of look at is that when we adjust that, yeah, you can see how these are changing, right? Here's the actual barb points that are being adjusted here. Those virtual points. So anyways, we've got this template. Let's look at how to actually maybe do this. In fact, you know what I'm going to do? I'm going to do maybe just one more real quick. One of the simpler ones that's not going to need any like noise or anything like that on it. We'll just do a really straightforward one. Maybe we'll do this guy over here. That looks good. So what I'm going to do is just copy all of this, I think. So since these are obviously SOP operators, what we can do is just do this like so, and just merge them together. I'm going to, reset the operations on these because we probably won't even need this. We'll see. But let's draw some more curves here and we'll get a feather out of this guy. Gee, there we go. Just hit control there. If you're not familiar with this, holding control when you hit the template button will actually like draw this as if it's real geometry in the scene. Even though it's templated, it's not where your actual view is set. It'll almost set the view there as well as like a secondary place to view from. So if you're not familiar with that, nice little handy feature. Let's see here. I'm just going to draw this as quick as I can. It's a kind of gross curve handle there. Let's clean that up a little bit. I can do better curve handles than that, right? Okay, cool. Looks good. Let's also draw the outside here. So we're just going to draw. Oops. I really like some of the improvements that they've made to this Bezier drawing node. It's very nice. Feels a lot better than it used to. And it makes things like this really feel like a real way to work. Sorry about my Bezier points. They're not going to be real nice, but oh well. He didn't come here for me to show you how to draw Beziers. All right, so what I'm going to do is I'm going to, we'll just leave this first profile on from shape like that. Great. It's a little split up here. I could probably move the end point of this a little bit. Let's go to F. I'll just pull this down. Great. We're creating a lot of barbs there, so it's kind of a little slower than I'd like it to be. But anyways, all right, so we've got another feather here. So let's name these two. We'll just call this one, sorry, it's right here. So we'll change the name of this. We'll just use $OS. So I'll just call this one, I don't know, cool turkey feather. And this one boring turkey feather. The neat thing here is that these are going to obviously both merge in here. We're going to array those to, get the closest point here. It's going to update the UV texture, and we can sample it as well. So that'll get the color as well. So now, kind of procedurally, we have this all doing its thing. We've got two feathers here. They both have color on them. All is good with the world. All right, so let's do that. I'm just going to do a file cache here. We're going to say feather templates like so. It's not a simulation. It's not time dependent. Save that to disk and then put a null down. There's our feather templates. All right, cool. So we've got those. Now let's do the actual kind of grooming part of this. All right, so let's say we'll do another geometry node here and we'll just say basic groom. Oh yeah, you're saying you feel like the curve node wasn't that much used. No, I think it was. I think it's just I think the more useful we make, it can be made, the better, the use cases for it is going to be. So yeah, I think it just depends on people's use, like if it's helpful, people are going to use it. You know what I mean? So, all right, let's do a sphere here from polygons. I'm just going to do this as a polygon. We'll up the frequency a bit. I don't know, 10 looks good. Make this a little bit bigger just so it's, yeah, exactly. Yeah, now more people will want to use it. I agree. That makes sense. The better we can make the tools, the more people are going to want to use them. Cool. All right, so sphere, let's just do let's add some normals if I can type. Add some normals, then we'll do a UV project. We'll project oh, that went behind there. Let's do this as a polar. Great. Doesn't really matter how the UVs look on this. I'm going to use the paint node on this, and you have to have UVs in order to do that paint node. So that's an important thing to kind of make a point of. So we'll just say this, we'll just do a null here, and we'll say GO2B groomed like that. Just so folks can understand when you open these up. All right, so this is where we're going to put down a few new nodes. We're going to use the guide groom at this point. This is where the actual workflow for hair grooming and feather grooming will kind of combine. They're going to be a lot of overlap now. So now we can take this guide groom. We can set a few things on here. There's some new features to this node if you've never used it before. I'm going to just change this to plant mode. I tend to like this a little bit better with feathers. I feel like I kind of want the feathers to be planted a bit more than drawn. It's tough. I mean, there's so many different ways you could obviously do this procedurally and put feathers on procedurally if you wanted to, and like just copy them and that type of a thing. But let's work this way. I'm going to show you how to do the plant mode first, and then we can kind of look at how to draw them. I'm not, like I said, I'm not a great artist, so I don't know, I don't have the technique to draw these things on properly. But anyways, so we're going to be using feathers here. So let's make sure we create and output feathers. There's a little button here to initialize some feather settings here. Like one important thing is to create and maintain the orient attribute, which is called barb orient. I don't actually want to override the width, I don't think. Great artist I am. I'm here for the technical stuff. That's what I'm here for. Okay, so what we need to do is we're going to do an object merge. Let's grab feather templates. We're going to say get feather templates, not templates, but templates. And then here, I'm just going to create a null. So I don't like to just reference this node here. So these are going to be our templates, and I'm just going to drag and drop this into here. This is going to be where we're looking. And from here, I'm like, why didn't that pick anything up? Oh, why didn't it pick anything up? It should. All right. Again, you can see that we're only seeing the center curves, so we know that we need to turn this on. Hooray. There we go. So we've got our templates here, and we've got our template groups. We've got our boring turkey feather and our cool turkey feather. So let's play with the cool turkey feather first. We've got our plant. I'm just going to template this geometry so I can kind of see where I'm planting these feathers. And let's maybe put a couple on here. So let's go here. I'm going to go into the view state, and we'll just plant a few cool feathers here. Oh, and I'm planting feathers, but it doesn't really look like a whole lot's happening. That's because I think the scale is really tiny on them. So let me change that. Let me just clear this real quick, and we're going to go to brush options. I'm going to make the default length. I guess let's just do it at like 0.3. That's like 30 centimeters. That's like roughly how long they are. You can always adjust those. And the segment count at 8 is good. That's basically just the guide segments. It's not the actual feather segments. So that's something to be mindful of. And I'm going to do single, like a single planted feather. And I think I want to turn off the interpolation. Let me just double check this here. I think this is not going to be too happy. Yep. So let's turn off the interpolation for right now. I noticed this before. I don't know if this is intentional or not, but I kind of noticed it and it felt like I wanted to turn it off last time. So actually I'm going to make this a little smaller because I was using bigger feathers when I was doing this before. So these are a little smaller. Okay, cool. So let's plant a couple of these cool turkey feathers around. So we've got this. I know this might be a little hard to see. Maybe I'll do this as solid geometry. We can probably see it a little bit better that way. So let's plant some cool feathers here, like so. There's some cool feathers planted. And then let's, on the outside, put some boring turkey feathers. So we'll put some boring ones around here. I'm going to turn this off just so maybe we can see this a little better. Cool. All right, so we got some cool turkey feathers and some super boring ones. All right, so obviously not a ton's going on here. Oh, little question off course. Python is used for the UI and C+ for the Vex, right? So if you're doing any UI stuff for the viewport, yes, Python will run that. Those are Python view states. I can't remember what for Vex. I think it's C++. I think for Vex. I don't know. I'm not a developer, so I don't actually know that language at all. So right now I'm thinking it's C++, but I could be way off. But I'm pretty sure that's what most everything is programmed in is C++. And then Python is like UI stuff a little bit. And I think a lot of Qt is done for UI as well, but I don't know. Yeah, you're welcome. I've had to learn a little bit of, I actually made my own view state recently, and that was crazy. I couldn't believe I could do it, but I got some help from Waffle Boy Tom. That's his handle online. He's really good at doing Python stuff. So I asked him a few questions about it. I was like running into some problems, and he helped me through a few things, but ended up getting it working. So yeah, I was very excited about that. As someone who's not much of a Python programmer, it was very exciting. All right, so we've got our guide room, but there's obviously some questions we have now where it's like, okay, well, how do we scatter the rest of our guides here? What the heck is going on? Blah, blah, blah. Let's try to tackle that a little bit. So what we're going to do is actually, you can do this where you can do, so what we're going to use is this interpolation mesh here. But this kind of shows you a quick little layout of how this works with the interpolation mesh. Now it shows you the skin input, shows you the guide input, and this will, you bring your guides in here, and then you bring your skin in here. And I think this might still error out. Nope, it works. So now we have sort of more or less this working, right? So this is doing pretty much what we want it to do at this point. We're actually generating all of these guide curves. But as you can sort of see, let me turn this off. Sorry. Turn that off, turn this on. We can see that it's following those and then it's trying to kind of interpolate over the rest of the geometry the best it can. This is what the interpolation mesh looks like, which looks a little funky, but as you can see, we actually have a point at each and every one of these individual guides that we've planted. And so this is how Houdini knows how to kind of send the rest of that data across the geometry and kind of blend between them. So it can actually look up information on these and figure out how to work with this. And so this mesh is, you can kind of play around with it a little bit here if you're not getting like a really good Where is it? There's a couple different modes for doing this. So if you do after adding guides, it's the best quality, before and after. Change. So this is basically just how it's doing the remeshing. And this one's better for interactivity. So if you're actually doing this interactively, you might want to do a different mode, but this is setting up some of the stuff we need. Now, I actually think it's a little confusing to have these extra nulls in here. So I'm going to get rid of those just because I think that can be a little crazy. And we're actually going to do one extra part here. So we're going to go back to this stage and we're going to do a texture mask paint. We're going to add one of those. And we're going to do a scatter. There's a new scatter node, scatter and texture mask. So what we can do here is we can take our geometry, again, just like we did before, we can paint it. So we can look at where these guides are and kind of give ourselves a limit of where these guides are going to be done. So we can kind of go like this and just paint along here like so. And one of the interesting things is that this last input is for masks. So if we do mask volume here and take a look at this, can actually see that this is going to, it should control how this is getting done. Let me see. Why is this? Actually, it shouldn't be. Oh, sorry. Got to turn the mask on. Texture primitive. There we go. So now you can see that we have a mask that's being driven by this texture primitive. And it's doing some really weird stuff because these guides are outside of the mask. So it's like, I don't know really what to do with that. So as we draw this here, it's going to remesh this, this interpolation kind of mesh for us. It's going to redo it every time as we're drawing. So now our mesh just looks like that. A little different. It's not going all the way around the geometry, and we can maybe make it a little taller here. Whatever. You can do it however you want to. We're like Bob Ross, just happy little accidents. So, okay, so now we're getting somewhere. However, we're still not getting the actual happy little feathers. Yep. So we're not actually getting these only sourced in those locations. So that's where this scatter and texture mask is going to come from. We're going to take the geometry up here. Let's see here. What is this going to be? That's going to be our rest. So I'm going to get rid of this. Boop. Okay. You know what? I should have known better than doing that, but I did it. Had a little crash there. Well, at least I don't have to worry about people seeing Houdini 20 on my desktop because it's out now. So there it is. Yeah, I should have known better than to do that because that was a lot of it. Put it directly into an error state when I cut that. I should have known better than to do that. I knew it was gonna error out. Yeah, it's all right. We're doing fine. Oh, well, I mean, we were doing fine. RIP. I'm going to try the old, there's a way to start up in manual. Well, we'll see. I'm going to start it up and just hit escape. We're going to give it a shot. See if we can make this work. I had it auto-saving, so there should be another file anyways. Did it too quick. Open crash file. There we go. Okay. All right, we're back in business here. So let's save this. Let's say, just in case, I don't want to write over that one. Let's see what we got going on here. Where's our feathers? This thing ain't happy. That's what I get for crashing it. All right, let's do this. Back up. That's close enough. Let's give that a shot. That's weird. Paint template. Let me just see what happened here. Definitely freaked it out quite a bit. Where's our geometry here? All right, let's just put a new guide groom in here and just call it a day. That's still painting. Cool. Okay, fine. All right, so let's just do another guide groom. Luckily, we didn't have much going on here. All right, we're back. We're back in business. So let's just throw a couple of these guys in here, create an output feathers. Set the feather settings. Template up here. We're going to do some... You can actually select these, although they're underneath right now. Right? Oh, right. That's not loading because I'm in the wrong section here. So I'm just going to go back over here. Ah, that was why it wasn't working. Because I had it set to the wrong thing. Okay. Anyways. I think we're back in business now. There we go. Brush options. We're going to do not draw, but we're going to do plant. We are going to do single. Turn off the interpolation, and default length is 0.3. All right, I think we're back. There we go. And then we will do some boring turkey feathers around the outside here. Cool. Then we'll do this texture mask paint. Couldn't see it because that was on still. Let's clear this out. We'll look at these feathers and we'll just use that as a reference. Paint this back in. Cool. Okay, so the question is from Black Voxels. Is it possible to make dynamic simulations with feather nodes, dynamic collisions? Yeah, for sure, 100%. That is a workflow that definitely works, and I can show you that in a minute. Or maybe the next stream, depending on how this goes. But yes, for sure, that can be done. Okay, so here's our guides. Cool. Looking good. The mask is going to be set back to the texture primitive. All right, now we're rocking and rolling. So what we're going to do here is we're going to take the geometry out here and the texture mask. We can actually... Now we can actually scatter points here. And what we're going to use this for is we're going to use this as our points that we're going to scatter our hair generation into. So Sorry, I'm just seeing why this is not I'm missing something that I'm obviously not clear with. Oh, per point. That's why. Cool. So there's our hair generation. It's happening just on those individual points that we scattered here. So this texture, this is basically scattering into that texture mask, the one that exists right here. We're scattering into it, and then we have hair being generated from it as well. So there we go. We're back in business. Sorry about that. So what we're doing is we're grooming, putting the guides in here. We have our texture mask that we can use here to kind of control where those, where we want the rest of them to be interpolated. We create a mesh to help with that interpolation as well. And then the hair gen kind of brings it all together in the end. So hopefully that makes sense to you. And isn't too messy. I think it's fairly clear what's going on there. It's a little messy, but okay. So we've got our feather templates here. So what we're going to do is we're going to do the interpolate. So we'll do a feather interpolate down here. So here we're going to take in our hair curves, or feathers in this case. We can also bring in the skin right there. And then we're going to bring in our feather templates on this end here. When we look at this, we should see that we're getting our feathers interpolated. Now the interesting thing that should be happening here, if you look carefully, which might not be the easiest thing in the world to tell, but you can see that in the middle here, at least, these have that noisy kind of thing going on with them. And then way out at the end, these have those non-noisy ones. So what we're getting is actually a blend in, out to these non-noisy kind of boring feathers. And if we look at this hair gen, this will give us a clue as to how that's working. So here you can see we have template names. You can see what side of the model they're on apparently, which is crazy. It does that automatically. And then from there, you can see the template weights. So this feather here is mostly the boring turkey feather. And then if we look around, probably somewhere down here, maybe, I don't know, we'll see. So there's some that are probably going to be heavier on that noisy kind of cool turkey feather. And then, slowly move across. So you can see the weights are here and these are the template names. So this is how that blending is happening. You can also set this interpolation to pick up based on name attributes. So you could set specifically what named feathers you want in certain spots. So that's possible as well. And you can also do it by group. So one interesting thing to keep in mind here is that this node has this resolution multiplier. And what this can do is actually change the resolution of these, these output interpolated feathers. And you might say, well, that's kind of weird. Why would you want to do that? And to that I say, well, there's a kind of cool reason. So if I do a feather visualize node, this will kind of bring us to that spot where we were at earlier, where we said, wait a second, we can see these feathers as like surface representations of themselves. And maybe that's a little too rough. Maybe we'll do 0.5. So now this whole groom is represented by 7,900 points, which really is not that many when you look at what's going on here. Just a decent amount of stuff happening. Probably can go a little lower than that. I didn't even see any difference in resolution there. So I'm going to do something just to make this see visually a little bit better. I'm going to turn the ID on just so we can actually see each of these feathers as a different color. And so now what we could do is we could do some grooming at this stage. So since this is pretty low, pretty low resolution, we can do a few different things. So let's just do the actual fun one. Let's actually do some grooming here. So what I'm going to do is hello? Guide groom. All right, so we're going to use the guide groom node. And I'm going to keep the visualization down here so we can see this. Keep it on ID. And if we come back up here and go into the view state, Interesting. So I'm going to make sure that this is working with feathers. So I'm going to just do create and output feathers, make sure that the setup is done there. And then I can actually just go out of that. I'm just making sure that this barb orient is being set properly so I don't mistype it or anything like that. And what I'm going to do is I'm going to just brush these feathers. I'm going to go into the brush options, maybe turn it down a little bit, add a little bit of maybe bend in there. I don't know. And what we can do then is start to play around with this and get some interesting grooming results. So now we can kind of move these around and brush these any different way we would want them to go, like so. Maybe a little too crazy. So let's do this. Let's reduce that a little bit. Let's turn the strength down a little bit on that maybe. Yeah, no problem. Good night. Thanks for joining. So here we go. We're just going to kind of groom these around, make them do something sort of interesting here. And obviously this isn't going to be anything too fantastic, but you know, it will give you a sense of what these feathers can actually do here. Like so. And there you go. You can see these are pretty, we're pretty responsive here. We're getting decent amount of frames per second with all of this. It certainly is not slowing my computer down drastically. And we're getting a good visualization of kind of what's all going on here. We can kind of play around with this a little bit and just, get this to work however we might want it to. So cool. Now we're starting to get somewhere with this. The last thing that we would want to maybe do is, let's see here. So we did the guide groom, we did the feather interpolate. So maybe let's take a look at throwing these into a quick simulation. We've got a little bit of time maybe left before I'm done here. So there is actually a feather surface, and I believe this is what we're going to want to do. So let's just grab those. Oops. So one thing that's weird here is I've noticed that this, the root of this feather definitely does some weird stuff. And in fact, we can just do a curve output for that. Oh, hello. That's interesting. I don't know why that's happening. Oh, we can just do this. Just doesn't seem to be liking that too much, but okay. So now we've got all these feather surfaces here. And you can see that this is making this surface based on where those barb points are. And what we could do here is we could do a feather resample. Just get this down to a really reasonable, representation. So let's just do this, resample the shaft down, maybe something like that. Be good. Resample the barbs. We don't need quite as many barbs. Maybe just something like that. Cool. And what I'm going to do here, let's see. I'm just going to need to pin these points to the surface in order to do some vellum-y stuff. So why don't I do this? I'm just going to do an object merge just to pull this down here. And I don't think I'm going to need these guys anymore. So we don't need to pull that along with it. I'm just going to say get surface. just so we don't have this crazy big amount of huge geometry. I'm going to do a peak here just to kind of push this out a little bit, and I'm going to group this here. Points. We're going to pin these guys down. I'm not going to enable all bounding regions, bounding object, and how much should we pick this out by? Just hello. Too much. Just a little bit. Looks like we have those all pinned down, so that's cool. I think there's a group expand here. Yep, there is. Can I expand point groups? Kind of feel like I can't actually. Oh yeah, there we go. Perfect, I can do it that way. So we're just going to pin a bunch of these to the sphere. Like so. That should be good. So those will be our pin points. And then... oh, good night, Black Voxels. Sorry, I think you probably said that a while ago, but good night. Thanks for joining. All right, so let's do a vellum cloth. We'll do that. Pinpoints will be this here. And then let's just do a vellum solver. Yeah. It's probably not super happy because of some weirdness there. Oh, you're still here. All right, cool. Let's do this. Let me just change this feather resample a little bit. And I'm going to change the thickness of this because I bet you it's too thick. Yep, that's part of the issue. It's too thick. Much too thick. All right, let's also, and I have my, yep, exactly. We're getting there. We are getting there. I'm going to turn this up a little bit just to make it maybe just a little less. Oh, you know what? I probably also need to add a substep in here. Is probably going to help a bit too. Yeah, there we go. That's actually better. I always forget to do that. All right. That's so stiff. Oops. It's funny when you watch it in slow motion, you're like, oh, that's moving way too much. But then when you see it in real speed, you're like, oh yeah, that's fine. All right, let's I think we want to dampen that movement a bit. Yeah. Cool. And then you know what I'm going to do? I'm going to have some wind blowing through this. So I'll do a pop wind. Have this blowing in the, which axis is that? X. Ooh, too fast. Too fast. Let's see. Is that not showing up here? That's weird. All right, there we go. We're getting some feathery movements. Just going to turn down the air resistance a little bit. It's weird. I feel like sometimes this works in here and sometimes it doesn't. It's really strange. All right. Well, it's not the greatest simulation in the world, but it works. And, it's doing its thing. So now one might ask, well, we've got this simulation going, but don't we want our feathers back? The answer is yes. We do want our feathers back. So we've got these surfaces here. And let's do a feather. There's a word for it, and my brain's not working quite right. Feather deform. There it is. All right, so for this one, we want our geometry to form, which is going to be the feathers. We can take our skin and our VDB. Then what we're going to do is we're going to take in our, let me just save this. Take in our rest deformers and our animated deformers there. That should be working. The deformer type is going to be surfaces. And yeah, I think we're getting a weird little viewporty thing there. There we go. And now we've got our feathers deforming just like that animation is. And now if you look at these are actually our low resolution feathers. And what we could do instead, here, you know what? I'm going to go back here. I'm going to save this. We're going to leave these as the high resolution feathers. And we're going to resample these. Yeah, that still seems to be the same resolution. So that's cool. So this here, we've got this. Yeah, exactly. We've got segments hard written there. So that's going to be exactly the same. It actually probably didn't even update at all. And so now should be getting the same kind of thing, except we have our super high resolution feathers. The only thing I think that we're calculating here is in this feather deform. So let's see if we can write this out to a file cache, which you'd want to do anyways. And we'll say deforming feathers. And time dependent. Let's save it to disk in the background. Let it do its whole thing here. There we go. So the one thing to keep in mind here is that this is treating the deformation as the deformer as a subdivision surface. So even if it's a kind of really low resolution, it's going to get a nice kind of smooth deformation across it, which is really nice. Any chance to get a tutorial for how to create a dynamic tree in Vellum and kin effects in the future? Yeah, maybe. Certainly something worth adding a little suggestion in um, the Discord server for sure. See if anybody else has any interest in that as well. I have some Vellum stuff that I'm going to be doing. I think maybe next week? Question mark. But anyways, I think if we play this back, we're going to see that we're going to get pretty okay performance. I mean, it's not. Oh, sorry, I'm up there. That's why. There it is. There's the performance. Not bad. Now, granted, we have some interpenetration here, but that's because these started interpenetrated. So if you do a better job beforehand of tweaking that, it will be better after the fact. There is also a feather de-intersect. What do you call it? De-intersect node. My brain forgot the word node. So if you were to take this, since this is almost done, I'll play with this in a second. We done down here? 5, 2, 1, done. Cool. All right. So if we take the up here, we do a feather de-intersect. There we go. This will take a second to start up because again, OpenCL. It's got to do some compiling. Let's see if this actually de-intersects it at all. Sometimes it works, sometimes it doesn't. In this case, where they're kind of separated like this, I feel like it can sort of act a little funky. Oh, yeah, it looks like we've got some that are separated a little bit. It's probably not perfect, but it's doing some stuff. Yeah, so basically you can set which direction it's trying to do the layering when you're de-intersecting, and the thickness and resampling. I think I found better results when turning that off, but anyways. Yeah, you can play around with that too. That might help de-intersect and stop some of that weirdness from happening at the very beginning of that simulation. But hopefully that's kind of interesting to take a look at. I mean, you've got a whole, kind of simulation going on here. It's kind of cool. I mean, it's 151,000 points. It's not, it's nothing to like sneeze at here. It certainly is a pretty reasonable amount of feathers. It's not perfect or anything like that, but it gives you an idea for what certainly is possible. And this feather deform, by the way, doesn't just work with it's going to simulate back to that point. Probably should have actually cached the Vellum solver, but that's okay. It can work with other things as well. It can work with curves. It can work with the actual feathers if you simulated those. So what you could also do is if you didn't want to calculate the entire feather like surface, you could calculate just the barbs themselves, like kind of just the curves, like the guide curves themselves. If it was like a background character or something like that, you could do that and get a much cheaper simulation cost that way. So that would be something you can do and deform the feathers that way with even quicker simulated geometry. But I mean, that Vellum solver goes pretty quick. So not too bad. Cool. Well, if anybody has any other questions about this workflow as a whole, I'd be happy to answer them. So I'll give you a second to kind of formulate any last thoughts and throw them into the chat. But I think we're going to be wrapping up soon anyways. So just let me know what you think and what, where you are, and if you've got any questions or things that you'd like clarity before we sign off for the evening. Sorry, I muted myself so I wasn't making mouth noise. I always forget that. I can hear myself. You guys can't. Sorry. So I've been looking forward to doing this for a while. What I was saying. Very much looking forward to this, and I think it's a cool tool set. I think there's a lot of really nice features and parts to it. If you are interested in a much more artistic kind of look at how to make some nice final results, I would check out the Intagma tutorials. I know that they just put those out recently, and those guys are amazing and do amazing art and teaching and all that kind of stuff. So much better than what I can do in a couple of hours here. But hopefully this gets you a better idea of this workflow. I think it might be worthwhile to maybe at one point do a little talk about using the feather procedural in Solaris, so you can get that nice Karma XPU speed. But for right now, I think just being able to play around with it and see how these things work is good. And if you want to check out a little bit more about Intagma, oh gosh, if you don't know about Intagma, go see their stuff. That's half of where I learned Houdini from. They're fantastic. Sign up for their Patreon, whatever, dude. Just throw money at them. They're fantastic. They're great. And Moritz is one of the guys that does the machine learning operators. So some cool stuff that those folks do. But yeah, maybe at some point we'll look at the feather procedural. But if you want a better hint at that, check out the content library. There's the eagle scene from the release stuff, and also the splash screen file is actually there, so you can play around with that as well, which is kind of cool. You can take a look at how they built that and created that. So now that you've seen how some of these tools work, being able to open that up and take a look at it, I think will make a ton more sense. So you won't be kind of trying to figure out what does each of these nodes do. It'll hopefully make just quite a bit more logical sense when you look through it. So anyways, I think that'll be it for tonight. Thank you guys so much for joining. I appreciate all the comments and questions and people talking in the chat. I know we kind of get towards the end of bedtime for everybody over in Europe as we're going here. So we people drop off as we kind of get further and further through the evening. But I appreciate everybody talking, and keep an eye out for any further announcements. I think I'm going to be doing MOPS Mondays bi-weekly. And next week I can't do it, so I think I'll put an announcement out when I'm going to do another MOPS Monday stream. And Wednesdays will still be happening. If you're looking for the schedule, I try my best to keep the schedule up to date on the website, so it's there for you to take a look at. HoudiniHangout.com. You can grab that. But other than that, that's it for the evening. Thank you all so much for joining, and I'll see you guys next time. Have a good night. Bye, everybody.